Okay, so today we're going to look at properties of logs. So you want to have your log reference sheet from yesterday handy, would be nice. And this is going on page 76 when we're done. Like for real, tape or glue it right when you're done, make it happen today. Okay, so we're going to start off by looking at the product property. We went over all these yesterday. We put on our little reference sheet, but we'll rewrite them here. So when I take the log of an argument that is multiplied, I can expand that into addition. So log base b of m plus log base b of n. And remember that goes in both directions, so I need to be able to expand and condense using this property. So it only works if my logs have the same base. These both have a base of 3. So this is going to become log base 3 of 9 times 5, which then becomes log base 3 of 45. Okay. So then I have log of 6 plus log of x minus 3, which is log base 10, right? And so I'm going to change that to log of 6 times x minus 3. So when I distribute that, that gives me log of 6x minus 18, and that's the best I can do. All right, so then I have addition here, same base because these are natural logs. Notice that it's the addition, when the addition of two completely separate logarithms, not addition or subtraction in the parentheses, right? So when I'm adding these, excuse me, I can condense them to a natural log of 4x squared times 3x cubed. So that just becomes the natural log of 12. 3 times 4 is 12. X squared times x to the third is x to the fifth because we add our exponents, and that is the best I can do there. Okay, so now we have condensed. Now we're going to expand. This is log base 10 of 72. So I can actually expand this in a few different ways. I don't have anything specific here I have to do because there are different things that multiply to give me 72. We'll go with 8 and 9. So this can become log of 8 plus the log of 9. Well, 6 times 12 is also 72. So another option could be log of 6 plus log of 12. You don't have to have two answers here, but there's more than that. It could be 2 and 36. I mean, we've got options, but something that would make sense there will work. Okay, so this is 9/10. Now we are expanding, and it says expand using the product property, right? So I'm expanding using the product property, which means I need two things that could add or that could multiply to give me 9/10. So I could do 9 and 1/10. That works. So it could be the natural log of 9 plus the natural log of 1/10. That works. Or I could do the natural log of 3/5 plus the natural log of 3/2. That works as well. Okay. Because this says use the product property, so when I have two things being multiplied in here, that's what I'm splitting them up to be. You've got options because they're not actually just showing you that it's two things being multiplied together. Those are not the only two options on either one of them. Lots of other things could happen. All right, so log base 5 of x squared minus 4. Now remember, this whole minus thing in here doesn't do anything for me. I need this to be multiplication or division to be able to do anything with it. We are told to use the product property, which means I'm using multiplication. So I need to factor this. So this factors into x plus 2 times x minus 2, which means this would become a log base 5 of x plus 2 plus log base 5 of x minus 2. There you go. Okay, so then we have the quotient property. Quotient property, log base b of m divided by n, that splits up into subtraction. So log base b of m minus log base b of n. So then I have this log, or natural log of 96 minus the natural log of 6. So remember the two logs have to have the same base. Well, they're natural logs, so they do. So this becomes a natural log of 96 over 6. So 96 divided by 6 is 16, so that's equal to the natural log of 16. And we're not touching a calculator here because it says condense into a single logarithm. It does not say to evaluate the logarithm, so I don't actually care what the value is of that. All right, so 8x, the log of 8x to the 10th minus log of 4x squared. So I have the same bases here, which is base 10. So this is going to give me log of 8x to the 10th divided by 4x squared. So 8 divided by 4 is 2. And then x to the 10th over x squared gives me x to the 8th, because my exponent rules tell me that I subtract, rules we should know. All right, so then again, I have two logs with the same base. I'm subtracting. And I've got log base 7 of the square root of 40 divided by the square root of 5. All right, now I can simplify the square root of 40, but I'm not going to, because when I have these divided, even though I don't have to rewrite it this way, so I'm going to write it over here so you know you don't have to. It's the same thing as this, which means I can reduce now. So this is going to give me log base 7 of 40 divided by 5 is 8, so that's still the square root of 8. It doesn't jump out of the square root or anything. And then I need to simplify that, so that is going to, in the end, give me log base 7 of 2 square root of 2. Now it says expand using the quotient property. So I need two numbers that are going to divide to give me 8. And again, I have options here. So I can make this into log base 3. See, I can get 8 a few different ways. I could do 48 divided by 6. So this could be the log base 3 of 48 minus log base 3 of 6. Or I could do log base 3 of 64 minus log base 3 of 8. What do you think about that one? And the reason we're even doing this where you can have different options like this is when you're using this to solve, basically I can take that and I can make it into anything I might need to match something else, since I have some options here. But as long as when I condense it back together, 48 divided by 6 is 8, 64 divided by 8 is 8. I don't know which one it actually came from, but it doesn't matter because overall those things have the same value. All right, so the natural log of 3/4. So we're expanding using the quotient property. I can do this a couple of different ways. This is the natural log of 3 minus the natural log of 4. That's the most basic and probably obvious, easy way to do that. But that's not the only answer. I could do then like the natural log of 3/2 minus, think about what would have to go there, because I'd have to take this divided by the next one, natural log of 2. That works as well. So again, just depending on why you would need to change it to maybe match something else as you're solving, there are lots of answers to these that you could have. Here, log base 10, so this is going to be log of x minus 7 minus log of x plus 1. There you go. So those are your product and quotient properties. Think about your options on these, and when you're arguing with your neighbor about who's right and who's wrong, you could both possibly be right. Okay, so our power property, log base b of m to the n power, this power just gets to come out front, so this is equal to n times the log base b of m. My directions here say to condense into a single logarithm. So 3 times the log of 6 means that 3 is going to be able to become my exponent. So I'm going to get log base 10 of 6 to the 3rd power. And that is going to equal log of 216. Once again, it just asks me to condense. It doesn't ask me to evaluate, so it doesn't matter what I evaluate it as. All right, so log base 4 of 81, got 1/2 of that, so that 1/2 becomes the exponent. So I'm going to get log base 4 of 81 to the 1/2 power. That is the same thing as the square root of 81. Got to know what your rational exponents do. And so this is just log base 4 of 9. All right, 15. This x minus 1 is being multiplied by the natural log of 4, so it becomes my exponent, and I get the natural log of 4 to the x minus 1 power, and that's the best I can do there. Now I'm going to expand using the power property. There we go. So this is log base 2 of 5 to the x. Those x's are really hard to read on here. I don't know what it looks like on the video, but so this is my exponent, so it's going to come out front, and so this gives me x times the log base 2 of 5, and that's the best I can do on that one. All right, so to condense or expand this one, I need to rewrite this as the natural log of 2x plus 1 to the 1/3 power. That's the same thing as taking the cube root. So now that I have an exponent, that exponent can come out front, and I'm going to get 1/3 times the natural log of 2x plus 1. And I hope that you have all broken the habit of your slashy fractions. This is what I mean by slashy fractions. No, no, no to this. They need to be little horizontal fraction bars that look like this. Okay, so if I'm supposed to expand using the power property, I don't have a power here, so I need to fix that. Well, I can do a couple of different things. I have some options here as well. I can rewrite this a few different ways. I can rewrite this as log base 6 of, well, one way I can get my exponent is just bringing that 64 to the numerator by taking 64 to the -1 power. And that would give me then -1, or just the negative log base 6 of 64. So I can't write a 6. 64. So that's one option. Let's talk about a couple of other options here. I could take this and rewrite this as log base 6 of 1/8 squared. Right? That's another way to rewrite that, which means then I could expand it as 2 times the log base 6 of 1/8. I could also rewrite this as log base 6 of 2. Now, since that came out of the denominator, it's got to be a negative, so 2 to the -6th power. So this could also be -6 times the log base 6 of 2. So all three of these things here actually have the same value. So you could pause this, and then instead of worrying about the fact that it's base 6, because whatever base it is, that didn't really play into anything that we did, we can just pretend like this is base 10, and then on your calculator, type in negative log of 64, get your answer. Type in 2 log of 1/8, get the answer. -6 log of 2, get the answer. And notice that they're all three the same. It's just different ways to write it to represent that number. Okay? And so you'll have options on your assignment There's more than one right answer to some of these, not all of these. We don't need to get crazy creative, but I do want you to be able to think through the fact that you could do them different ways, and sometimes which way you choose is dependent on what's going on in the problem itself. All right, let's look at the back. So we're going to condense each expression into a single logarithm. So I've got a couple of things going on. 2 times this plus 3 times this. So I cannot condense this using my product property right now because I've got numbers outside of here. So these numbers that are outside of here have to become the exponents. So this is going to become log base 4 of 9 squared plus log base 4 of 2 to the 3rd power. Then I can condense this more using my product property here. And so this is going to become log base 4 of 9 squared times 2 to the 3rd power. And so to figure that out, this is going to be 9 squared, which is 81. So this is log base 4 of 81 times 2 cubed is 8. Right? So then let's just think about this and not try and rely on that calculator all the time. 8 times 80 is going to be 640 because 8 times 8 is 64. And then 8 times 1 is 8, so that's 648. So this becomes log base 4 of 648. That's my answer. All right, so then I have log of 80 minus 2 times the log of 4. They have the same basis, so that's good. So this 2 first has to become the exponent. So I'm going to have log of 80 minus log of 4 squared. So that gives me log 80 minus log of 16. Oh, 80. And then log of 80 over 16, because when it's subtraction it becomes division, so this just becomes the log of 5. All right, so I've got to condense these. So I've got this 3, which is out here, so it's going to become an exponent, so the natural log of p times q to the 3rd power. That whole thing is to the 3rd power, plus the natural log of p times q squared to the 4th power. So I first need to fix my exponents here. And this is going to become, let's see, natural log. So this 3 gets distributed to both of them. So this is going to be natural log times p cubed q cubed plus the natural log of, this is going to be p to the 4th, and then a power to a power means you multiply, q to the 8th. So then when I condense them, and this is going to use my product property, this is going to be the natural log of p to the 3rd, q to the 3rd, times p to the 4th, q to the 8th. Then I got to make sure that I know what's going on with exponents. So when I multiply, I add the exponents. So this is going to give me the natural log of p to the 7th times q to the 11th. All right. Now, got this whole thing, excuse me, to the 1/2 power, which means I do not want to start by changing the power. Like, this doesn't get to just become an exponent over here. It doesn't work that way because this isn't just one log. Okay, that's a log property. But this right here, these have the same bases, and I can condense it using my product rule. So this becomes 1/2 times, oops, I guess I need that. It'll catch up. Hang on. Okay, times the log base 5, and then since this is addition, this becomes x to the 6th times x cubed. So that's going to become log 1/2, of log base 5 of x to the 9th. So now this can become an exponent. So this becomes log base 5 of x to the 9th, and then this is to the 1/2 power. Well, power to a power, you multiply. So this is log base 5 of x to the 9/2 power, which we would rewrite as log base 5. So that 9, this is x to the 9th, but that 1/2 is the square root of that. That's what we get. All right, so now we're going to condense the next one. Okay, so the difference, one of the differences between this one and this one was that this 1/2 didn't belong to one single log, and I don't get to, I could distribute it, but we're working from the inside out, didn't really want to do that. So here, this belongs to this one, so it's going to become this exponent. So this is going to give me the natural log of 64 to the 2/3 power minus the natural log of 8 squared. So I could handle the exponents right now, or I could wait. I'm going to wait and condense it because I want to show you a couple of different ways that you could look at this. Just again, depending on what situation you're in or what you're trying to do here. So option 1 would be to kind of leave everything as is for right now. So we'll have the natural log of 64 to the 2/3 power over 8 squared. Okay, so we could, if these two had the same bases, then I could take care of these exponents as far as subtraction goes, because that's what happens when you have division, but the bases have to be the same. Like, this is kind of like having x and y. If I have x and x, then I can look at my exponents. So this 8 squared does give me 64, so I'm just going to go ahead and do that. So this is the same thing as the natural log of 64 to the 2/3 power over 64. Okay, now I do not get to cancel the 64s out, but this is really 64 to the 1st power. So I'm going to put that 1 there that we normally don't put, just so we can think about what's happening. So when you're dividing and you have the same bases, then the rule is you get to subtract your exponents. So this is also the same thing as the natural log of, well, 2/3 minus 1 is going to give me 64 to the negative 1/3 power. Okay, so I could look at it that way. I could get rid of that negative exponent, and this would be the natural log of 1 over 64 to the 1/3 power. Well, 64 to the 1/3 power is the same as the cube root of 64. So in order to simplify it, the cube root of 64 is 4. So this gives me the natural log of 1/4. That's one option. The other option is going ahead and taking care of the exponents at the beginning here. So when I condense it, I get the natural log of 64 to the 2/3 power over 8 squared, right? So let's just go ahead and evaluate the numerator and the denominator here and get the natural log. Well, 64 to the 2/3 power is the cube root of 64 squared. Okay, but you don't have to square 64 first. You can take the cube root of it first, and then 8 squared is 64. So the cube root of 64 is 4. This is a natural log of 4 squared over 64, which is the natural log of 16 over 64. And then that gives you the natural log of 1/4. So it's up to you whichever way makes more sense to you, but just understand, I realize you may have a calculator in your hand right now. You will have to work through some of these without a calculator in your hand. So with that said, don't just think, oh, well, I can push buttons, it doesn't really matter. It does matter, because you still have to reason through this and know how to work through those things when you don't have the calculator in front of you. Okay? All right, so let's look at 24. 24 is similar to 22 in that I have something out here outside of these parentheses, so I don't get to just make this a big old exponent over here. But I do have an option up here that we didn't talk about, is that I could distribute. I could distribute this -2 into these two terms. I wouldn't suggest it. It's going to be way easier if you don't. Just like this 1/2 being distributed in there, it's actually easier if you don't. So we're always just going to work from the inside out. So, I mean, you can try it if you want, and you're just going to see that the work is a lot uglier than if we were just to leave it. So if I'm going to work from the inside out, I'm going to leave this negative 2 out here for just a minute. I can't do anything to that log of 15 for right now. But this 1/2 can become the exponent over here. So this is going to be plus log of 1/9 to the 1/2 power, right? So that still have that negative 2 times the log of 15 plus, well, 1/9 to the 1/2 power is the square root of 1/9. The square root of 1/9 is 1/3, so this is plus log of 1/3. So when I condense those, I get negative 2. This becomes multiplication, so this is negative 2 times the log of 15 times 1/3. So 15 times 1/3 is 3. So this is negative 2 times the log of, I'm sorry, it's not, it is 5, duh. 15 times 1/3 is 5, not 3, 5. Then this becomes my exponent. So this is going to give me log of 5 to the negative 2 power. So 5 squared is 125. That negative gives me the reciprocal, so that's the log of 1/25. Alrighty, these are fun. All right, number 25. Okay, so the log of 72 minus 1/3 of all of that, so we're going to work from the inside out again. And this gives me this 2 times the log of 4. That 2 is going to become the exponent. So I'm going to have log of 72, kind of try and write small here, minus 1/3 times, well, I'm going to go ahead and kind of skip a step here. The this becomes the exponent, so it'll be 4 squared, which will be 16. So I have the log of 16 plus log of 32. So still working from the inside out, that's adding. They've got the same base, so I'm going to use my product property. So this is equal to the log of 72 minus 1/3 times the log of 16 times 32. That's a parentheses also. So I need to do 16 times 32. That's going to give me the log of 72 minus 1/3 times, I don't need my parentheses anymore, times the log of, well, 16 times 32 is 512. Right? So that 1/3 is going to become an exponent, and that gives me the log of 72 minus the log of 512 to the 1/3 power, which is the same thing as taking the cube root of 512. So remember, if you don't know your perfect cubes, or you're not sure if it's a perfect cube, then you can do this the same way you do square roots, whether you did the birthday cake or whether you do whatever. I know two numbers that multiply to give me 512 are going to give me 16 and 32. And so when you do that, so like the cube root of 512, and so I got 16 and 32 over here, then 16 can become 4 and 4, and this can become 4 and 8. And what you're looking for are not pairs of numbers, but it's supposed to look like a 3, but sets of 3. So right now I have 3 4s, so I'm just going to stop on that. But then 8, isn't 8 just 2 times 2 times 2? And so I have another set of 3 there. So you take out your sets of 3, which means I take out all of these 4s, they come out as a 4. I take out all these 2s, they come out as a 2. I have nothing left underneath. My answer is 8. So the cube root of 512 is 8. So now I have log of 72 minus the log of 8. Now I'm going to actually condense those, and that's subtraction, so it'll become division. So this gives me the log of 72 divided by 8, which in the end is just the log of 9. All right, I got interrupted, so I don't know what the last thing I said was, but let's move on here. So I've got 3/2 times log base 3 of a, so this is going to become an exponent up here. and then minus, and then this 1/4 is going to become an exponent to this right here. Now I've got two options here. I can leave this as minuses, which is what I'm going to do. I could change this to plus a negative and make this a negative 1/4, but I would really rather have this be minus than have a negative exponent, because the same thing ends up happening in the end anyway. So this will become log base 3 of a to the 3/2 power minus log base 3 of 16a squared to the 1/4 power. All right. We'll leave this as log base 3 of a to the 3/2 power minus log base 3, and then this 1/4 I'm going to distribute to both of those. So the 4th root of 16, so anything to the 1/4 power is the same as the 4th root. Square root is 4, then square root of that is 2. So the 4th root of 16 is 2. And then this would be a squared times 1/4, and so 2 times 1/4 will be 1/2. So 2 times a to the 1/2 power. So then this can become, I'm going to use my quotient rule. This is going to give me log base 3 of a to the 3/2 over 2a to the 1/2 power. And so I have the same bases here on the a. The 2 stays in the denominator. And then this is a to the 3/2 and a to the 1/2. And so since the bases are the same, I subtract the exponents. So 3/2 minus 1/2 is 2/2, or just 1. So I'm just left with an a in the numerator, and that's my answer. All right, so now we are expanding the logs. It actually says expand, but we're going to expand. And so these are two things are being multiplied. This x times y cubed. So I could split it up as x and y cubed, or it could be xy and y squared. But I want to split it up in the most logical way here. So I'm going to make this into log base 7 of x plus log base 7 of y cubed, because then I have this exponent that I can bring out to the front, and I get log base 7 of x plus 3 times log base 7 of y, and that allows me to get it as kind of separated out as possible. Okay, so this division becomes subtraction. So I'm going to have the natural log of m cubed minus the natural log of n to the 7th. Then those exponents come out to the front. 3 times the natural log of m minus 7 times the natural log of n. All right, so I have log of the square root of a cubed times b. So I'm going to first rewrite this as the log of a cubed times b to the 1/2 power. So that 1/2 is going to come out to the front of that log. So I get 1/2 times the log of a cubed times b. Then I'm going to separate these two things in here. It's going to give me 1/2. Now that 1/2 is being multiplied by this whole thing, log of a cubed plus log of b. And then the 3 can come out to the front, so I get 1/2 times 3 times the log of a plus log of b. Then I distribute, and I'm going to get 3/2 times the log of a plus 1/2 times the log of b. And I have that's expanded as much as I can expand. All right. So this 4 is going to start by coming out into the front here. So this is going to give me 4 times the log of 4 c squared over d. Then that is going to be 4, and I can expand this part in here, log of 4, or log base 4, sorry, of c squared minus log base 4 of d. So that's equal to 4 times 2, or times the log base 4 of c minus log base 4 of d. Then I can distribute, and that'll give me 8 times the log base 4 of c minus 4 times log base 4 of d. And that is as expanded as I can get. All right. Number 31. This 2 comes out to the front, so I get 2 times the natural log of 5 times p cubed, q to the 4th. Then I can actually expand this into 3 parts, so this is going to be 2 times the natural log of 5 plus the natural log of p cubed plus the natural log of q to the 4th. And then my exponents come out to the front. Get 2 times the natural log of 5 plus 3 times the natural log of p plus 4 times the natural log of q. Then I distribute my 2. So I get 2 times the natural log of 5 plus 6 times the natural log of p plus 8 times the natural log of q. Last one. So I have natural log of the cube root of x over x squared plus x. So I'm going to use my quotient rule here. And even though this will be like to the 1/3 power, it's not the whole fraction to the 1/3 power, so it doesn't get to come out to the front right now. This is going to give me log base 2 of x to the 1/3 power minus log base 2 of x squared plus x. So then this 1/3 comes out front, so I get 1/3 times log 2, or base 2 rather, of x minus, and then this is addition. I don't get to split that because it's addition. This has to be multiplication in here, but I can factor this. This is minus the log base 2 of x times x plus 1. So I can expand this part because I've got some multiplication going on in here. So I'm going to rewrite the first part, 1/3 times log base 2 of x minus, now I need parentheses here because I'm going to split this into 2 and this whole thing is being subtracted. So it's minus log base 2 of x plus log base 2 of x plus 1. So then to finish my expansion, I get 1/3 log base 2 of x minus log base 2 of x plus log base 2 of x plus 1. But then look at what I have right here. I have 1/3 minus this, which is like a 1 there, right? So 1/3 minus 1, because these two things are exactly the same. Like I can't combine these as far as you're combining like terms. But if I have 1/3 of this thing minus 1 of this exact same thing, that's going to end up giving me negative 2/3 log base 2 of x plus log base 2 of x plus 1. There is my expansion. And we're done. Glue this in now. Or tape it in. I may have used a glue room right here. Taping might be better, but do it now.